All right, we're doing the first part of 5.4, exponential and log equations. We have done some of these already. So exponential equations, we're solving for something. If the equation is exponential, what do? We already did the first one, okay, where we're changing the base. So I'm just going to go ahead and give you an example of that. So changing the base, let's just say I have 2x, or 2 to the power of x equals 8. I know I can go ahead and get a base of 2 by setting it to 2 to the power of 3. Canceling my bases, and x equals 3. We've done that before. We should know how to do that. You guys already took a test on that, okay? So that's pretty easy. Now, there are multiple ways you can solve when you do not get the same base. So for example, 2 to the power of x equals 10. I know I cannot get the same base here. So there are multiple ways to solve this. If you have a tutor who does it differently than how I do it, as long as you do it correctly, it's the same. Keep in mind, for these answers, we're gonna put them in calculators and get decimals. So however you solve it works out. I am gonna check the work, but I use natural log. If you don't use natural log with your tutor, that's fine. Okay, I'm not picky about that. As long as the work is correct and we're getting the same answer, I'm okay with it. So please pay attention to how we're doing this, and whatever works for you works, okay? So we are still solving for x. Now, we have to figure out, okay, how do I solve for x? I can't use the base of 2 like I said, so I'm using natural log. And just as an example, what I do to one side, I have to do to the other. So if I'm using ln, I have to do it to both sides, and then I'm gonna move my exponent to the front and solve it that way. So we are gonna go ahead and do some examples on the next slide, and you'll see it in practice. But what this will look like is I'm gonna have x times ln of 2 equals ln of 10. And then I'm getting x by itself by dividing, okay? And then we did this last class. All we're doing is solving for that, and we could totally just plug that into our calculator and get our answer. So this is how we're solving for exponential equations if I cannot get the same base. So we're gonna go ahead and do some examples on the next slide. All right, let's go ahead and look at example number 1. We've done something like this. What do I have to do with my bases? I'm going to go ahead, because I have the same base, I'm just going to go ahead and cancel out those bases. And because I canceled out those bases, I'm going to have negative x squared equals negative 3x minus 4. And looking at it, I'm going to have an exponential equation. I'm going to add x squared. Or yes, I have an exponential equation. I'm going to go ahead and get, set it equal to 0. Add x squared to both sides. I'm going to end up with x squared minus 3x minus 4. Now, I have a quadratic. How am I solving for x given a quadratic equation? What do I have to do here? I have to factor, okay? And we have been using factoring since the beginning of the school year. So we should all know how to factor. What am I going to get factoring? X, what? X plus 1 and x minus 4. Set them both equal to 0. And my answer is going to be x equals negative 1 and x equals a positive 4. So I have 2 answers for x. Both of these are correct. All right, looking at example number 2, very similar question. Again, you're just canceling out that e, or the base, because they're the same. And you're going to get 2x equals x squared minus 8. Keep in mind, I want to keep this positive, so I'm not moving this to the other side. What I'm doing is I'm moving that 2x by subtracting 2x to both sides. After subtracting 2x to both sides, I'm going to end up with 0 equals x squared. I'm writing it in standard form. Minus 2x minus 8. Again, I can factor this. If I factor correctly, what am I going to get? Good. X minus 4, x plus 2. Set them both equal to 0, and x equals a positive 4, x equals a negative 2. And again, both of these are my answers. Now, looking at number 3, can I get the same base? Can I get a base of 2 to the power of whatever that gives me 42? No. So what you have to do is you have to get the term with x by itself. And like I said, I'm using natural log to solve this. So me using natural log, I'm going to go ahead and use ln for both. Keep in mind what you do to one side, you also have to do to the other. Knowing our properties from last lesson, I'm going to take that exponent, and what am I going to do with it? I'm going to move it to the front. So now I'm going to have x times ln of 2 equals ln of 42. Remember, we're trying to get x by itself. So how do I get x by itself here? What do I have to do? I'm going to go ahead and divide by ln of 2 to both sides of my equal sign. That should be a normal size 2. Let me fix that. These are going to cancel out, and I'm going to have x equals ln of 42 over ln of 2. Now, taking my calculator, I'm going to go ahead and plug this into the calculator. Go ahead and plug it into the calculator. Please make sure you are closing that parentheses on the 42. All right, go ahead and plug it into your calculator if you didn't already. Again, just a reminder, make sure you close that parentheses on the 42. So if you plugged it in correctly, your answer should be... All right, for this question, we're going to round our answer to the thousandths place, and that's 3 digits after the decimal. So again, if you plugged it in correctly, you should have approximately 5.392, and this would be my answer. Keep in mind, we are rounding, so you should have that squiggly line as your approximation. All right, going to number 4. Okay, trying to get that 5x by itself, so I have to get rid of that 2. How do I move that 2? What do I have to do? 2 times 5 to the power of x. So I have to divide by 2. Okay, dividing both sides by 2, because of multiplication, the opposite or the inverse is division. So now I'm going to have 5x, 5 to the power of x equals 16. And solving for x, I cannot get the same base, so I'm going to go ahead and use ln on both sides. So using ln on both sides, I'm going to go ahead and also move that x to the front. So looking at it, I'm going to have x times ln of 5 equals ln of 16. Next, get that x by itself by dividing by ln of 5. These are going to cancel out. And I'm going to get x equals ln of 16 over ln of 5. And again, go ahead and plug that into your calculators. Just a reminder showing you what it should look like. Once you push ln on your calculator, parentheses pops up. 16, close the parentheses. It's super important that you close that parentheses. Divided by ln of 5. That's what it should look like on your calculator. And then if you plugged it in correctly, your answer should be x is approximately, rounding to the thousandths place, 1.723. This one rounds up. Okay, you had 1.7227, And that 7 determines if you round up or keep it the same, and in this case, you round it up. So this is what you should have for number 4. All right, please make sure you guys check your work. And again, you will get a calculator for this. All right, following the same process here. We're still doing the same thing. I have to get that e to the power of x by itself. So how do I get rid of 5 or plus 5? Good, I'm gonna go ahead and subtract 5 to both sides of my equal sign. I'm gonna end up with e to the power of x equals 55. And then I'm gonna go ahead and use my natural log ln. And don't forget, I have that exponent. I want to move it in front. Properties. I'm going to have x times ln of e equals ln of 55. What do we know about ln of e? What's going to happen there? Good. They're going to cancel out. So I have my answer. X equals ln of 55. Go ahead and plug that into your calculator. And if you plugged it in correctly, you're going to get x is approximately 4.007. All right, going to number 6, same process. Trying to get that e to the power of x by itself. So first thing I have to do is add 7. Okay, doing the inverse operations to both sides of my equal signs. E to the power of x equals 30. And using natural log, I'm going to use ln. Move that x to the other side. X times ln of e equals ln of 30. I'm just writing it out to write it out so it's neat. But if you already know at this point, you need to cancel out ln of e. You could even cancel it out here. X equals ln of 30. Go ahead and plug that into your calculator and you're going to get approximately 3.401. All right, for 7 and 8, you're going to need a little bit more space. Please follow along for this one. This one's going to be a little long, but nothing we can't do because just, think of it as algebra. Okay, algebra 1, just solving for x. So looking at this, same thing, okay? First thing I'm going to do is I'm going to add 4 to both sides. Leave yourself some space. Add 4 to both sides. So I'm going to have 2 times 3 to the power of 2x minus 5 equals 4. Then I'm going to go ahead and divide both sides by 2. 2's are going to cancel out. I'm going to have 3 to the power of 2x minus 5 equals 2. Okay. Now can I get the same base here? No. So I'm going to go ahead and use my ln. What I do to one side, I also have to do to the other. Then knowing my properties, I'm going to take that power, my exponent, and move it to the front, keeping it in parentheses. So what is it going to look like? 2x minus 5 in parentheses times ln of 3 equals ln of 2. Same thing we've been doing before. I'm going to go ahead and divide by ln of 3 on both sides. And just rewriting what I have, 2x minus 5 equals ln of 2 over ln of 3. Keep in mind, we are not done. We have to get x by itself. All right, next step after this is I'm going to go ahead and subtract 5 to both sides. Or not subtract 5, add 5 to both sides. So I'm going to have 2x equals ln of 2 over ln of 3 plus 5. I know this is going to look super ugly, but we can solve it. You just have to follow the steps. Then how do I get x by itself? Divide it by 2. So I'm dividing everything by 2. rewriting it so it looks a little neater. I'm going to have x equals, you know what, I'm going to bring it to the other side just so everything could be in one space. I'm going to have x equals ln of 2 over ln of 3 plus 5, everything over 2. So this is what it looks like. Now, how are you plugging this into the calculator? Very carefully. However, if you want to do this first, ln of 2 divided by ln of 3, get that answer, add 5, get that answer, then divide by 2, you can. Or you could plug it all into the calculator, but keep in mind if you make mistakes, regardless which way, it will be wrong. So do it in steps if you prefer that. Solve it out together if you prefer that. But I'm going to go ahead and solve it, write my answer, and let's see if you get the same answer. Then I'll tell you how I did it. So if you plugged it into your calculator correctly, your answer should be x is approximately 2.815. So go ahead and check your work. All right, how did I plug it into the calculator? Like I said, there are multiple ways to do this. You can do it in steps. If you want, like I said, you could do your natural logs first and then add 5, then divide by 2, but I plugged everything in together. However, if you're not careful with parentheses, if you're doing everything together, it's going to be incorrect. So when you're plugging everything in, the top must be in parentheses. Okay, because all of that is my numerator. My 2 is my only denominator for the fraction. So what does it look like? I did open parentheses. I started with an open parentheses. Then I pushed ln. Something like this pops up. Plug in that 2. Make sure you close it. Then I did divided by. Again, I pushed ln. This popped up. Put my 3 in, close it. I added 5, then I closed the top. Okay, so this portion right here is just for the top part. Okay, it has to be in parentheses. Then I clicked or selected, whatever you want to call it, divided by 2, and I got my answer. So you could do it this way, you could do it in steps, but most of you seem like you got it. All right, let's go ahead and try the last one, number 8. Still the same process. I'm gonna go ahead and first, I'm gonna subtract 4 from both sides of my equal sign. Okay, now I have 6 times 2 to the power of x plus 5 equals 18. Divide both sides by 6. I'm going to still have that 2 to the power of x plus 5 equals 3. I cannot get the same bases, so I'm going to use my natural logs to solve. Move that exponent to the front. So I'm going to have x plus 5 in parentheses times ln of 2 equals ln of 3. Next step is I'm going to divide by ln of 2 to both sides of my equal sign. So now I'm going to have x plus 5 equals ln of 3 over ln of 2. And then my last step here would be to subtract 5 from both sides. Just going to keep it over here. And I'm just going to write that answer over here. And don't forget you have to plug into the calculator. So it's going to look like x equals ln of 3 over ln of 2 minus 5. Go ahead and plug that into your calculator. And if you plugged it in correctly, your answer should be x is approximately negative 3.415. 3.415. And just showing you again what this one looks like, I don't have to put the whole top in parentheses, so I just did ln, open parentheses 3, closed it, divided by ln, 2, closed it, minus 5. That one was pretty easy. So again, this is a calculator section. Please make sure you know how to use them.